Welcome to today's deep dive. You know, when you picture a woodland mushroom, you probably imagine something like quiet, just a cute little yellow cap sitting peacefully on a dead log.
Right, yeah. Like it's just minding its own business.
Exactly. But if you look closely at Hypholoma fasciculare, which is commonly known as the sulphur tuft, you're looking at a complete illusion. I mean, it's a classic Dr. Jekyll and Mr. Hyde situation.
Oh, absolutely. Above ground, sure, it looks like a harmless yellow blanket. But down in the soil, on a microscopic level, it's running this ruthless biofluorescent chemical weapons factory.
And the wild part to me is that the very same aggressive toxins it uses to dominate the forest floor, well, they actually have world-changing pharmaceutical potential. Our mission today is to unpack all of that.
So to really grasp the medical breakthroughs, we first have to look at how aggressive this thing really is. I mean, it doesn't just passively decompose dead wood.
Right, it actively conquers territory, doesn't it?
Yeah, it literally gasses its neighbors. It pumps out volatile organic compounds, specifically a class of chemicals called sesquiterpenes.
Wow, so it's basically using airborne or soil-borne chemical missiles.
That is exactly what they are. One of them, alpha-murylene, is designed to just completely halt the cellular growth of rival fungi.
Like Pozolythus tinctorius.
Yeah, exactly, which is this symbiotic fungus that actually helps tree roots absorb nutrients. But the sulfur tuft, I mean, it doesn't care at all. It just floods the soil with this compound, shutting down the competitors so it can steal the real estate.
Man, that is ruthless. And it's waging this turf war while glowing in the dark, which is just crazy to me.
It really is. Under UV light, specifically in the 365 to 395 nanometer range, the gills and stem emit this ghostly green biofluorescence.
And that's not just some accident of nature, right?
No, no. The working theory is that the glow acts like a neon diner sign for nocturnal insects. The bugs are drawn to the light, they crawl over the glowing gills, pick up the spores, and then inadvertently act as mules.
Just spreading the mushroom's territory even further. So it's like a glowing turf war gangster expanding its empire. But what really blows my mind is how it's manufacturing the weapons for this war.
Right, the organohalogens.
Yeah. It produces massive amounts of adsorbable organic halogens, or AOX. We're talking up to 3.23 milligrams per gram of dry mycelium every single day.
Which is a huge amount for a fungus.
It is. And wait, aren't halogens usually, toxic synthetic pollutants
Yeah.
like industrial bleach or pesticides? You're telling me nature is running a chemical plant on a rotting log?
I know, it sounds impossible, but it uses something called metabolic plasticity. Basically, the mushroom acts like a master chemist. It's constantly tweaking its recipe based on the soil it sits on.
So if the dead wood is rich in nitrogen, what happens then?
Then the fungus synthesizes a highly specific antibacterial compound. It's called 3,5-dichloropyenic acid, and it uses it to fend off bacteria.
Meaning it custom builds a complex antibiotic on the fly just for that specific environment.
Precisely.
Yeah.
But if the wood is nitrogen limited, it completely switches gears.
Oh, wow, really?
Yeah, it alters its internal manufacturing process to output entirely different, currently unidentified halogen compounds that just work better in poor conditions.
Okay, so it's a hyper-aggressive, pollutant-producing stump mushroom. But here's the real aha moment for you listening. This exact chemical aggression is what makes it so valuable to us.
Absolutely.
Yeah.
Because we can harness this natural weaponry to clean up human-made medical waste.
Which is a massive deal because hospitals generate incredibly toxic wastewater, right?
Right, especially with complex cytostatic drugs. Those are heavy-duty anti-cancer drugs used for chemotherapy.
And traditional water treatment plants can't easily break those down.
No, they really struggle with it because the chemical bonds in these drugs are practically bulletproof.
But for the sulfur tuft, breaking down tough chemical bonds is literally just what it does to survive.
Exactly. A 2024 study showed that the sulfur tuft's mycelium acts like a set of specialized molecular scissors. Its enzymes can just snip apart the complex toxic bonds of these cancer drugs.
That's incredible. And they tested this in liquid media, didn't they?
They did, yeah. And the fungus successfully degraded up to 96% of the drug vincristine.
96%. So even though the mushroom itself is highly toxic to eat, it's packed with fasciculol toxins that will cause severe vomiting and paralysis.
Yeah, I definitely do not eat it.
Right, do not eat it. But its microscopic aggression is essentially acting as a bioincinerator for our most dangerous pharmaceutical pollutants. It tears them apart at the molecular level.
It completely reframes what this organism is. It is not just a poisonous woodland hazard. It is a highly adaptable cleanup true capable of treating a massive global water crisis.
Just by doing what it evolved to do. It's amazing. And before we wrap up this deep dive, I want to leave you with one final, totally mind-bending detail.
Oh, the genomic studies. This part is wild.
It really is. Genomic studies reveal that if you silence just one of the genes responsible for producing these chemical weapons, the mushroom's entire physical shape morphs.
Right. It goes from a standard ball shape into a completely different rigid or fluffy structure.
Which completely blurs the line between what a fungus makes and what a fungus is.
It really makes you wonder, yeah.
So ponder this. In the fungal world, are a creature's chemical weapons and its physical body actually the exact same thing? Keep that in mind the next time you see a quiet, picturesque yellow cap sitting on a stump. Dr. Jekyll is always hiding Mr. Hyde.